My name is Jing Wei. I'm a senior lecturer at School of Chemical Engineering at the University of Queensland. Now let's talk about the next generation of the glass. We chose to work on this topic because we want to solve the broken screen problem for all mobile phones. If you think about it, it's actually very expensive. At the same time, a huge environmental issue for all of us. We have to spend zillions of dollars every year to fix our mobile phones, but also spend an equal amount or probably even more money to try to recycle those materials. Normally they're very difficult to make and very difficult to recycle. So if we can make them unbreakable, we will be able to save a lot of energy, save a lot of money, and that will be making our life much easier and much better. I'm pretty sure that we are all well aware of the problem of the traditional glass, which is typically made from silicon oxide or aluminum oxide. So if you have a very powerful microscope and you keep zooming in, if you can see the atoms, you will see all the inorganic glass, which we see every day. They are very densely packed together, which means if we apply external pressure, there is no space for the energy to be released. So that leads to be the breakage, the broken of the glass. Regarding the impact of our new glass material to the conventional glass, if you think about it, the glass material is over 5,000 years old. And currently there are only three types of glass material. So we have inorganic material, polymeric material, and of course metallic material. All glass material has been recognized as the fourth generation of the 5,000-year-old material. And it has attracted significant research interest because we try to combine the property of metallic component as well as organic component. That's really combine both rigidity of the glass but also the processability of the polymeric component. If we think about the potential application for our new glass, our aim is to replace the current inorganic glass everywhere around us. For example, the windscreen in our cars, it is very heavy. Essentially, that's a piece of stone. You have to carry those pieces of stone around you everywhere you go on a daily basis. If we can reduce the weight of the windscreen without compromising their rigidity, compromising their safety, we will be able to save a lot of petrol and potentially energy around us for the transportation. Our new glass can also be made into the typical windows, make them breathable, so that means we can reduce the use of air conditioning. That's another opportunity. In terms of manufacturing of the new glass, you will be surprised how easy and how quick and how cheap it can be made. Just like conventional glass, we just grab the raw material from minerals and directly use what we call the ball mill. Essentially, that's just a grinding process. We put everything into one jar and use some mechanical force to grind the powder all together. After 30 minutes, we will have our glass material. It is a new material. It is a super exciting opportunity, but at the same time, there are a lot of challenges we need to overcome. The first thing is we want to synthesize those materials based on our needs. We want to use the material for membrane for separation. We want to use the material for screens. We want to use it for windows. They all require different properties and they all require different functions. So we want to tailor the material based on their targeted applications, which means we need to go back to the recipe to try different recipe of the material and try to find the best combination. That is a huge task because we use different metallic component, we use different organic component. When you put them together, that's almost endless combinations of possibilities. That means we have to try really a huge amount of different recipes to find the best one. That is the major challenge for our current research. Well, I did talk about the problems we face, and that is an opportunity for us. If you go to a chemistry lab, you will find all the students, they try to make solutions, mix them together, and hopefully something magic will happen. I would say that is totally waste of our energy and our creativity. So that is why we want to introduce robotic arms together with machine learning to help us to do all the tedious, repetitive work. So in our lab, what we're looking at is try to use robotic arms to do all the basic material handling, synthesis, and characterization. Using robotic arms is not only time-saving, but also increase the reliability of our sample handling. That means all researchers and students can spend their valuable time to think about the really novel, cutting-edge, and exciting research ideas, rather than spending hours in the lab trying to do the synthesis. Well, machine learning is a pretty interesting concept. Essentially, it's use a computer using all the different algorithms, mind-meltingly string algorithm, I would say, to help us to make decisions. It's kind of like you will have the eureka moment in your brain. You have the moment when everything comes together very nicely. This happens occasionally to us, but we want to reproduce the eureka moment using computer on a very frequent, on a daily basis. It will happen to every single data set we get, to every material synthesis, and to every experimental data we try to look at. So that will significantly speed up the material development and also the advance for the science and engineering aspect. That's what we want to bring machine learning into engineering, and that is what we want to achieve. Talking about future research, of course, we want to study and understand their fundamental science for these new exciting materials. We want to know more about their properties, we want to know more about their function, so that we will be able to tailor their property and design our material based on different application scenarios. At the same time, as an engineer, I'm also very eager to translate those new exciting materials into something really cutting-edge devices. So hopefully, at least, we can make the broken screen a thing of the past in a few years.